வணக்கம். நீங்கள் பார்த்துக் கொண்டிருப்பது உங்கள் கோல்டன் தொலைக்காட்சியின் செய்திகளை வாசிப்பது உங்கள் அன்பு நண்பன் கமல். பார்ப்போம் இன்றைய தங்கவயல் செய்திகளை. தொடர்ந்து ஆன்லைன் சேனலில் உங்களுக்கு 2 சேனல்லேருந்து ஒளிபரப்புன்னு வரும். உங்கள் நாலேஜ்க்கோசரம் எஸ்பெஷலி 10th படிக்கிற பசங்களுக்காக தயவுசெய்து பாருங்கள். இன்றைக்கி பார்க்கக்கூடிய சப்ஜெக்ட் என்னன்னு பார்த்தீங்கன்னா ஜென்ரல் சயின்ஸ். அதுலேருந்து ஃபிசிக்ஸில் வந்து எலக்ட்ரிசிட்டி அதை பற்றி டீப்பாக எக்ஸ்பிளைன் பண்ணியிருக்காங்க. பாருங்கள், வீட்டில் இருந்து பார்த்துட்டு அதை பற்றி எதனா டவுட் இருந்தால் தயவுசெய்து கேட்டு தெரிஞ்சுக்குங்க. புக்கை ரெஃபர் பண்ணுங்கள். ரெஃபர் ஆகலைன்னா உங்களுக்கு கன்ஃபியூஸாக இருந்துச்சுன்னா சம்மந்தப்பட்ட டீச்சர்ஸ் கிட்ட ஃபோன் பண்ணுங்கள். இல்லை வந்து எங்களுக்கு கமெண்ட் பாக்ஸில் கமெண்ட் பண்ணிங்கன்னா கண்டிப்பாக அவங்க உங்களுக்கு அதுக்கு விளக்கம் தருவாங்க. இன்றைக்கி கிளாஸ் எடுத்து பார்த்தீங்கன்னா சிஸ்டர் அமலி, மிஸ் வினோதினி, மிஸ் மைதிலி, இவங்க 3 பேரும் சேர்ந்து வந்து உங்களுக்கு புரிகிற விதத்தில் ரொம்ப அழகாக சொல்லி கொடுத்துருக்காங்க. பாருங்கள், சப்போஸ் அதில் புரியாத ஒரு எதனா இருந்துச்சுன்னா தயவுசெய்து கமெண்ட் பாக்ஸில் கமெண்ட் பண்ணுங்கள். உங்களுக்காக ஆன்சர் பண்ணுறதுக்கு 3 பேரும் காத்துனுக்குறாங்க. அப்படி இல்லைன்னா உங்கள் பக்கத்தில் எதனா டீச்சர்ஸ் இருந்தால் டவுட் கேட்டு நீங்கள் தெரிஞ்சுக்கின்னு இம்ப்ரூவ்மெண்ட் ஆகிறதுக்கு இது ஒரு வசதியாக இருக்கும். நன்றி, வணக்கம்.
The universe is like an endless room with endless treasures and secrets. The deeper we go into it, the more interesting it gets. Human mind is filled with immense curiosity to find out all the hidden secrets of the universe. This curiosity has developed from the visible phenomenon of nature occurring around us in our daily lives. Mankind has observed the nature's gift from the beginning of the universe. The burning fire out of stones and the heat emerging from the fire, the thunder, lightning, and a stormy night, sounds of thunder, the days and nights, the sun and the moon, and lots of other things that make the universe a wonder, provoke human mind to find out more about them. Physics is a Greek word which means knowledge of nature. Physics deals with the study of nature and properties of matter, energy, and their relationship. Physics include all kinds of matter. In smallest form, it includes atoms and the tiniest particles that make up an atom. And in larger physical forms, it includes stars, planets, and the universe. It includes energy in all forms like light, air, sound, magnetism, gravity, etc. In other words, physics teaches us about the study of naturally occurring objects that might not even have a shape, but are fundamentals in occurrence of universe. A brief overview. Physics, in particular, focuses on some of the most fundamental questions about our physical universe. Physics can also be described as the science dealing with physical quantities. In this regard, physics is widely considered to be the most fundamental and important of all the natural sciences. Physics and mathematics are closely related to one another. It could be said that mathematics is the language of physics. That is another way of better understanding what physics is. Numerical values, units of measurement, and similar concepts are all mathematical in nature and are used to describe physics in the most accurate and precise manner. Physics has several branches dealing with different forms of matter and energy in space and time. Acoustics, the study of sound and sound waves. Astronomy, the study of space. Astrophysics, the study of physical properties of objects in space. Optics, the study of propagation, behavior, and properties of light. Thermodynamics, the study of heat and its relation with energy and work. Geophysics, the study of the shape, structure, and composition of Earth and its crust. Atomic physics, it deals with the study of composition of atom apart from nucleus. Other than these, physics has various other branches that we'll cover over a period of time.
dear friends. I'm Sister Amali.
I'm Mrs. Vinodani. And I'm Miss Maitli.
We welcome you all for this online classes.
Today in this class, we will discuss about an important chapter in physics.
We hope that you will enjoy this online classes, children.
Dear friends, as you see, here are some of our household appliances are arranged. I want you to come and see them and identify them by name. Each of them is very unique and wonderful, but they have something in common. Can you identify that? Yes, they all function because of electricity. So today we are going to learn an electrifying topic, which is electricity. Look at this chart, students. Here are some of ways how we manage life without electricity. This world is so colorful and wonderful. During the day, we see this colorful and wonderful world in and through the help of the sun. But during the night, what helps us to see this wonderful world? It is the electricity. So we are going to learn about electricity. There are two types of electricity. The first one is static, and the second one is dynamic. What do you mean by static? It is at rest. And meaning of dynamic is in motion or moving. Okay. We are not going to deal much about static electricity, but the dynamic electricity. Under this dynamic electricity, I am going to deal about what is an electric current and what is an electric circuit and what is the potential difference. We are much familiar about air current and water current. Flowing water constitute water current and blowing wind constitute air current. Similarly, we have electric current. What does it constitute? It is the flow of electric charges. When electric charges are passing through any conductor, then we know that there is an electric current. It is defined as a rate of flow of electric charges. The electric current is denoted by the letter I. The formula is Q by T. Q is the electric charge and T for time. The SI unit of electric current is ampere, and we use ammeter to measure the electric current. Mobile phone or laptop. This indicates that the battery is low. What do we do when the battery is low? We take the device and connect it to a charger. What does it happen? From the main, we get electricity passed on to the device and it gets charged. There are two types of electric charges, positive and negative charges. Positive charges are proton and negative charges are electron. In the circuit, it is the electrons that are passing through the wire, the conductor. What is conductor? Conductor is any material that allows the electricity to pass on. What do we call the materials which do not allow the electricity to pass on? they are called as insulators. I give some of the examples for conductors as well as insulators. Conductors are, most commonly used conductors are copper, aluminium, and insulators are rubber, plastic, wood. They are some of the examples for insulators. We have seen what is electric current. Now let us see what is an electric circuit. To learn about the electric circuit, I have made a simple circuit. You can see here there is a battery, 9-volt battery, there is a bulb and there are wires and there is a switch. So one end of the battery is connected to the bulb and the other end is connected to the switch. So when I switch it on, there is a closed path. Now observe this chart of an electric circuit. As we have seen in the experiment, we have a battery or combination of cells. What is the difference between cell and a battery? If a single cell is used, it is a cell. More than one cells are used, then we call it as combination of cells or battery. So we have electric bulb and ammeter. Ammeter is used for what? It is used to measure the electric current. As I said, electricity is being passed, the charges flow from the positive terminal and it comes back to the negative terminal. And the direction of this electric current is taken as opposite side of the flow of current. So this is the direction that is opposite to the flow of current. Current flows like this. So we have the definition for an electric circuit. It is a continuous and closed path of an electric current. So now in this circuit, it is a closed path. So if I switch it off, what happens? There is a gap is created. It is no more a closed path. When I switch on, closed path is created so that the electrons are able to pass through from one end to the other end. Okay. Just imagine, here we have a dry cell. Okay. I am going to take this cell that is placed here, going to take it to the other side. What am I doing? Certain amount of work is done to take this cell from that end to the other end. So similarly, the electric charges, when it moves from one end to the other end, we call it as electric potential. Electric potential. How much work is done in order to move a charged particle from one end to the other end is called electric potential. Okay. Next we are going to learn about potential difference. Okay. We have two beakers, beaker A and beaker B. Both are filled with water and there is a pipe connecting these two beakers, and you observe the level of water in both the beakers. They are same. Will there be any flow of water from beaker A to beaker B or beaker B to beaker A? Absolutely no, because the level of water in both the beakers are same, equal. So in case if I add some more water to it, some more water I am adding to the beaker A. Now what will happen? Automatically the water from beaker A starts moving and coming to the other beaker. So also in potential difference. Potential difference is nothing but voltage. It is the voltage that pushes the electrons from one end to the other end. And like how where more pressure is there, from there it is coming to the lower area. Okay, that is called potential difference. So, potential difference. The difference of an electric potential between the 2 points, between any 2 points, is defined as the potential difference. To take one charge, one electric charge, to carry one electric charge from one point to the other point is defined as the potential difference. The SI unit is volt. The formula is W by Q. What is meant by W? It is work done. Q is charge. The work done to take one unit charge from one end to the other end, one point to the other point, is potential difference. So we have voltmeter. Voltmeter is used to measure the potential difference. So this is the voltmeter. So if we connect this voltmeter to this simple circuit, we can find the voltage. Now I can tell you the voltage of this battery. It is a 9 volt battery, and voltage of this battery is 1.5 volt. Similarly, if you connect this ammeter into this circuit, we can also measure the electric current that is passed through this circuit. So students, I hope you have understood these simple 4 concepts: electric current, electric circuit, electric potential and potential difference. I would like to give you a homework. You can see how I have done a simple electric circuit. At home you also can try using batteries of different voltage and construct simple circuits, and you can show to your teachers. Okay.
Children, now we will discuss the relation between potential difference and electric current. Observe the circuit connection here. An ammeter, a nichrome wire, cell of 1.5 volts and a plug key are connected in series, and a voltmeter in parallel. The connection is according to this circuit diagram. First we use one cell as a source in the circuit. The readings in the ammeter for the current and in the voltmeter for potential difference are noted and tabulated in the table. The experiment is repeated for 3 to 4 cells. The ratio of V to I is calculated for each case. What do you observe here, children? Yes, all the values are same. From this experiment, we find that V by I is constant for each case. When we plot a graph between V and I, taking current on x-axis and potential difference on y-axis, the VI graph is a straight line passing through the origin. As the current is increasing, what is happening to the potential difference? Good. The potential difference also increases linearly. This experiment was observed first by George Simon Ohm, a German physicist, in the year 1827, called Ohm's law. This we can write it as V by I is equals to constant. V by I is equals to R. R is the proportionality constant called as resistance. This is the mathematical expression for Ohm's law, which gives the relation between potential difference and electric current. What is this resistance? When free electrons drift inside a conductor, they frequently collide with its positive ions or atoms. The motion of the electrons is opposed during the collision. This property of the conductor to resist the flow of charges through it is called as resistance, and the electrical component which is used to create resistance in the flow of electric current is called a resistor. This is a rheostat, children, a device used often to change the resistance in a circuit. The SI unit of resistance is ohm, denoted by a Greek letter omega. Now let us learn about the factors on which a resistance of a conductor depends. The resistance of a conductor depends on its length. As the length of the wire increases, the resistance also increases, which means the resistance of a conductor is directly proportional to its length. The second factor is on its area of cross section. As the area increases, the resistance decreases. That is, resistance of a conductor is inversely proportional to its area. The third factor is nature of its material. The arrangement of atoms is different for different materials. For example, copper offers less resistance than the tungsten. The fourth factor is temperature of the conductor. When the temperature is more, the resistance also increases. Resistors in various combinations are often used in various electrical gadgets. There are two methods in joining the resistors together. The first method is resistors in series. This is the circuit diagram. Children, can you tell me how the resistors are connected here? That's right. The resistors are connected in a row. Resistors are said to be connected in series when they are chained together in a single line, resulting in a common electric current flowing through them. The second method is resistors in parallel. This is the circuit diagram. Resistors are said to be connected in parallel if both the terminals of the resistor is connected to each of the terminals of the other resistors, resulting in a common potential difference across the resistors. Now let us see what are the advantages and disadvantages of this connection. In series connection, as the resistors are connected in a single line, if one component fails, the other components also do not work. As the same amount of current flows through the circuit, it is impractical to connect an electric bulb and an electric heater in series because they need currents of widely different values to operate properly. But whereas in parallel connection, even if one component fails, the rest of the components work properly. This is because the parallel circuit divides the current through each electrical appliances. Now tell me, children, which connection will you prefer? Yes, parallel connection. That's why the parallel circuit arrangement is used in domestic wiring. Hope you understood the concepts explained in this class, children. As a homework, answer these questions referring your textbook. Define Ohm's law. Mention the factors on which resistance of a conductor depends, draw a circuit diagram to show the resistors in series.
Children, let us discuss about a few other topics of electricity, and now we are going to discuss about heating effects of electricity. Children, you know what is this? It is a battery. So the battery is the main source of electricity which converts chemical energy into an electrical energy. During a chemical reaction, you can see the potential difference is created between the two terminals, which allows the electrons to flow in an order through the circuit where the resistors are connected in series. So as we are going to discuss about heating effects of electricity. What are the heating effects of electricity? How does a conductor get heated? So you can see here a conductor is connected to a battery. So what happens when a conductor is heated? A conductor gets heated when an electric current passes through it. A steady current is maintained in a conductor which generates heat. So let's begin with what are the heating effects of electricity and how does a conductor get heated. A conductor gets heated when an electricity passes through it or when an electric current passes through it. So when a steady flow of current is maintained in a conductor, some amount of heat is generated. Understood, children? When a steady flow of current passes through a conductor, some amount of heat is generated. Now how this heat is produced? In a conductor, when electricity passes, how does an heat is produced? You know that the electrons, as they are moving, collides with an atom present in the conductor. A collision, due to the collision between an atom and the electrons, kinetic energy is produced. And this kinetic energy in turn converted into heat energy. So that's how the conductor gets heated up. The unavoidable heat produced in the conductor. The unavoidable heat produced in the conductor increases the temperature and that's how heat is produced, and that's how heat is produced in the conductor. So the unavoidable heat produced in the conductor increases the temperature in the conductor. So when the temperature increase in the conductor, it alters the property of the components connected in the circuit. So we know that there are many devices which works under heating of electricity. Here you can see that an electric stove, an electric iron, an electric light, and so many devices work under electricity. So let me discuss about few devices which work under heating effects of electricity. So now let us discuss about the practical applications. Now let us discuss about the practical applications, how the electric devices work. Children, have you seen this bulb? Yes. This is an electric bulb. Can you tell me who invented this? It's scientist Thomas Alva Edison. So this electric bulb was invented by Thomas Alva Edison. And you can see here, it has a coiled filament which is made up of a tungsten metal. And this filament should have the capacity which can retain the heat generated when the current flows. And also, this filament offers high resistance and also high melting point. The filament of tungsten have a high melting point of 3380 degrees Celsius. Moreover, this bulb is enclosed by chemically inactive gases called as nitrogen and also argon, which prolongs the life period of the filament. What happens when an electric current flows through this bulb? The coil gets heated up, it becomes very hot and emits light. So you can see here the electricity is converted into heat energy, and in turn heat energy is converted into light energy. So here the 90% of electricity is converted into heat energy, and only a 1% of heat energy, electricity is converted into light energy. Next, we are going to discuss about fuse. Children, have you seen this fuse? Yes. So every home has a meter box, and every meter box have a fuse. These fuses are connected in series with the meter box. So what is a fuse? A fuse is a safety protecting device for the electric circuit and also protects the electric appliances against heavy current or heavy load. Got it, children? So fuse is a safety measure or a safety device which is used to protect the electric circuit and also electric appliances against a heavy load. You can see here the fuse has a wire which is made up of tin and lead alloy, and you can see this wire is fitted in a carrier of a porcelain, and this fuse wire is a strong wire which is having high resistance and a very low melting point. So you know, in India every home is distributed with a specified amount of electricity, that is 220 volts. When the current increases more than the specified amount of electricity, the wire gets heated up, melts and breaks the circuit. Therefore, this fuse helps to protect the electric connections or protect the electric circuit, and also prevents the spread of fire and protects the life and property. Understood, children? So today's homework, children, you can please refer the textbook and answer the questions. The first question is, state Joule's law. The second question, name the filament which is used in an electric bulb.
Dear friends, we hope that we have made the concepts clear to you. If you have any doubts, you can write it in a comment box.
Children, if you have any doubt in the chapter, you can contact your teachers.
Thank you, children.
இதுவரை நீங்கள் பார்த்துக் கொண்டிருந்தது உங்கள் கோல்டன் தொலைக்காட்சியின் செய்திகளை. எங்கள் செய்தியை பின்தொடர எங்கள் தொலைக்காட்சியை சப்ஸ்கிரைப் செய்து கொள்ளுங்கள். பக்கத்தில் இருக்கும் பெல் பட்டனை அழுத்த மறக்காதீர்கள். நன்றி, வணக்கம்.